Hello, and welcome back to another AP3 video. In today's video, we'll be going over SAT math questions, more specifically area and volume. We'll be doing easy, medium, and hard questions. The question asks the following: what is the volume in square centimeters of a rectangle with the length of 36 centimeters and the width of 34 centimeters? So what do we want to do? Well, we have a rectangle, so let's draw that really quickly over here. We have a rectangle, and it tells me it has the length of 36 and the width of 34. Now in your reference sheet, you can find the area of a rectangle by doing length times width, and that'll give you the area. So the length, so L equals 36, and our width equals 34. So what I want to do is multiply 36 times 34, and that will give me my answer. And if you plug it into a calculator, you get the answer. But solving it normally, I would do 36 times 4, which 6 times 4 equals 24. And then 4 times 3 equals 12, and then 12 plus 2 equals 144, so 36 times 4 equals 144. And now I just solve for 36 times 30. So I do 36 times 3, which equals 18, and then that equals 108, so then 1080. So if I do 1080 plus 144, I'm going to get 412 over here. To 1, I'm gonna get 1,224, making my answer D. Okay, let's do another question. The figure shows the length in centimeters of the edges of a right rectangular prism. The volume B of a right rectangular prism is length, width, and height, where L is the length of the prism, W is the width of the prism, and the height, and H is the height of the prism. What is the volume in centimeters of the prism? So let's see the information given. We're given that the volume of a rectangular prism is length times width times height, which are the corresponding information that's given. They're telling me that the length is L of the prism, so I'm gonna do that. Length is L of the prism, the width is W, and the height, is H. So which one's which? So if we look at the rectangular prism or the image, we can see that the length is 6, the width is 2, and the height is 3. So we have L equals 6, we have width, which equals 2, and height equals 3. So all we have to do in this question is just multiply all the numbers to get our answer. So if I do 6 times 2, I get 12, and then 12 multiplied by 3 equals 36, making my answer D. Let's do another question. The length of a square is 55 centimeters. What is the area in cm squared of the square? So I'm given the side length of 55. And what I want to do is find the area of a square. Now the good thing about a square is that all sides equal the same, obviously. So let me draw a square right over here. So I'm going to have 55 on this side, 55 on this side, 55 on this side, and 55 on this side. And to look for the area of a square, all I have to do is get two sides of a square and multiply to each other. So therefore x squared. So x would equal 55. So if I do 55 squared, that equals 3,025, making my answer C. These questions are really easy if you understand your formulas and how to use them. Not all of them will be on the SAT reference sheet, but most of them are easy to remember. Okay, now we're going to do medium questions. A manufacturing company produces two sides of cylinder containers that each have a height of 50 centimeters. The radius of container A is 16 centimeters, and the radius of B is 25% longer than the radius of container A. What is the volume in cubic centimeters of container B? So before we use anything, we need to understand what formula are we going to use for this type of question. We're given that the two sizes are cylinders. And if we look at our SAT reference sheet, we can see a cylinder right here, being volume equals pi radius squared height. So what I want to write is volume equals pi r squared h. And this is my formula for a cylinder. It's given on the SAT reference sheet. Therefore, you do not need to memorize it. So that's pretty convenient. So let's use the information given to look what we need to look for. So what are we looking for? We are looking for the volume of cubic meters of container B. So let's use the information given to figure out. So we're given that both container A and container B have a height of 50 inches. Therefore, H, let me do that in red, H equals 50 inches, or centimeters. My mistake. We're also given that the container A has a radius of 16 centimeters. But that information is not relevant. And you'll see why. Because we're looking for the radius of B, not A. A is given. But we need radius A to look for radius B. Because it tells us that the radius of B is 25% longer than the radius of A. What does that mean? What we want to do is multiply 1.25 by 16 to look for the radius of B. And why 1.25? Well, if we do 1 times 16, so 1 times 16, I'm going to get 16. But if I do 1.25, I'm going to get the radius of B being longer than 16 by 25%, or 1/4, depending on how you want to see it. So what we can do is multiply 1.25 by 16 to figure out the radius of B. So if I do 16 times 1.25, I am going to get 20. And you can fact check that by using Desmos, because using math on the SAT can be kind of difficult because you're always going to be given a lot of information. So in my opinion, the easy math, you always want to plug into a calculator just to make sure that you're doing it correct. So you do 16 times 1.25, you're going to get 20. So the radius of B equals 20. So R equals 20. And now what I want to do is plug that in now into the formula and get my answer. So the volume of B, or container B, equals pi, and the radius, which equals 20. So 20 squared multiplied by 50, or 400 multiplied by 50 pi. And if you multiply that, you're going to get 20,000, making our answer B. Okay, let's do another question. But before I do this question, I want to go over vocabulary about circles that are in this question, like diameter. So what is a diameter? If you don't know it, that is completely okay, because I'm going to go over it right now. So I'm going to draw a circle really quickly over here. So a diameter is just a line that crosses the circle. So it could be a line that goes like this, goes like this, that goes like this, that goes like this. You get the point, basically. If it crosses the middle, it is a diameter. So a line like that. A radius is a line that crosses the middle portion of a circle. So let me erase this line. So a radius will kind of look like this. Like that, right? It could be here, 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 here. They're all going to be a radius. So that's important to know. So for example, if I have that radius equals A, if radius is half of a circle, then there has to be another half for it to be a whole diameter. Therefore, diameter equals radius multiplied by 2. So the diameter in this example would be D equals 8 times 2, which equals 16. And that will be important for this question. So let's read the question now. So a circle has a circumference of 31 pi centimeters. What is the diameter in centimeters of the circle? So what can I do? Well, I'm given that the circumference is 31 centimeters. So let me write that. 31 pi centimeters. And if we look at our SAT reference sheet, we can see that we do have to find the circumference. We have the formula, which equals 2 pi r. And what are we looking for? The radius. So what do I want to do? So what I want to do, let me take out the cm, the centimeters. What I want to do is divide both by 2 pi, and I can find my radius. So if I divide both sides by 2 pi, 2 pi's cancel out here, and I'm left with 31 pi divided by 2. The pi's cancel out, and I'm left with 31 divided by 2. And if you plug into a calculator or you do it mentally, you're going to get 15.5, which equals radius. So what are we looking for? The diameter. As we said, let me draw a circle. So the radius is from any point of the circle to the middle. So this is our radius. The diameter is the full line. So diameter is this. Like we said, diameter has equals radius multiplied by 2. So I need to do 15.5 times 2 to look for my diameter. So 15.5 times 2 just equals 31, which is our diameter for this question, and that is our answer. Okay, let's do another question. A cylinder can containing pieces of fruit is filled to the top with syrup before being sealed. The case of the can has an area of 75 centimeters squared, and the height of the can is 10 centimeters squared. If 110 centimeters cubed of syrup is needed to fill the top of the can, or fill the can to the top, which of the following is closest to the volume of the pieces of fruit in the can? So what am I given? What am I looking for? We're looking for the closest to the total value of pieces of fruit that are in the can. We're given that it has the base area of 75 centimeters squared and the height of 10 centimeters. What I'm also given is that we need to figure out the total volume if 110 centimeters cubed of syrup is needed to fill the can to the top. So what I can do is multiply the base of the area and the height of the can to look for my volume of the cylinder. So if I do 75 cm squared or centimeters squared multiplied by 10 centimeters, that equals 750 centimeters cubed, and this is my total volume. So this total volume. So what I want to do is figure out the closest total volume of the pieces of fruit in the can if 110 centimeters cubed of syrup is needed to fill the can to the top. So what I can do is subtract 750 with 110, and I'm gonna get my answer. So 750 minus 110, that equals 640 centimeters cubed, making my answer C. See, pretty simple. Okay, let's do another question. In the xy plane shown above, squared ABCD has its diagonal lines on the x and y axis. What is the area in square units of the square? Well, because we have two diagonal lines in ABCD, we're able to conclude that this square shown above has four congruent right triangles. What are they, you might be asking? Well, if I draw two lines here and here, I'm able to see four congruent right triangles. And they're congruent because in a square, I have a total angle measurement of 360. And because every single side of a square equals 90 degrees, I'm able to have four right triangles as shown here. So what formula can I use to figure out the area of the square? I can use a triangle area formula. You might be asking, but why the triangle area formula if it's a square? Well, because what I can do is find the area of a triangle, multiply by 4, because there's 4 triangles, and then I figure out the volume, or the area, sorry, of the whole square. And if we look at our SAT reference sheet, so let me go over here, I see that to find the area of a triangle, all I have to do is multiply one half by base times height. So area of a triangle, A equals 1/2 base times height. So let's look at one triangle that's given. So if I count the spaces, let me erase these. If I count the spaces of the base, I have 1, 2, 3, 4, 5. So my base equals 5. And if I count the height, I have 1, 2, 3, 4, 5. And my height also equals 5. So then I plugged it in to find the area of a triangle, and then I get the area of my triangle. So 5 multiplied by 5 is just 25. So 25 divided by 2 equals area. And if I do 25 divided by 2, I'm gonna get 12.5 equals A, the area of a triangle. And like I said, to find the area of the square, I multiplied 12.5 times 4 to figure out my area of the square, because remember, this square has 4 congruent right triangles, and we only have the area for one triangle. So we multiply that by 4, we'll get the area of the full square. So if I do 12.5 times 4, I'm gonna get 2 when I multiply 0.5 times 4, and if 4 times 2 equals 8, 8 plus 2 equals 1. So I have 1 on this side, so I have zeros over here. And if 4 times 1 equals 4, and then 4 plus 1 equals 5, therefore I have 50. And 50 is the total area in square units of the square, making my answer C. Okay, now we're gonna do hard questions. And let me tell you, this question is not pretty if you don't understand it right away. But once you understand it, this question's actually not that bad. So let's look at it. Square A has a length that is 166 times the length of square B. The area of square A is k times the area of square B. What is the value of k? So I'm given two squares. But before anything of the question, I want to go over a concept that's really important for this specific question. So let's say, for example, I have two squares. One that's bigger, well, that's a rectangle. So let me redraw that. So let me have two squares. One that's bigger. I can't draw today. Wow. So let me draw a square, one that's bigger and one that's a little bit more smaller. So let's say that the small one has the side lengths of, let's say 1. So every single one has 1. And the side length of the bigger square is 9 times the length of the one. So each side has 9. So why am I going over this? And you'll see why. So to compare the area, if I do find the area of the smaller square, I'm gonna get 1. And if I find the area of the bigger square, I'm gonna get 81. Therefore, the area of the bigger triangle, or bigger square, sorry, is 81 times the area of square 1. And that's important for the specific question. So what we can do is, now that we understand how that works, is all I have to do for this type of question is multiply 166 times 166 to figure out how many times greater is square A to square B, because the ratio is always going to be the same, because square A is 166 times the length of square B, regardless if the number is 1, 2, 3, 4. Any number, it's always going to be k times greater than square B, or k times the area. So if I go to decimals and I plug in, so let me refresh decimals. If I do 166 squared, I am going to get a huge number of 27,556. So square A is 27,556 greater, or times greater, sorry, so I'm right over here, times greater than square B. And that is our answer, the 2,556. But let's make sure that is our answer. So let's say I have a small square, which each side length of 2. And I'm given that the side length of the other one is 166 times greater than the smaller one, square. So if I do 2 multiplied by 166, I'm gonna get 12, and 12 again, 13, and then 2 times 1 equals 2, so 332 on each side for the bigger square. And this is important because you'll see. So if I do find the area of the smaller square, I'm gonna get 4. And then to find a bigger one, I am gonna multiply 332 2 times, or multiply 332 times 332, or 332 squared. And I'm gonna get a huge number of 110,224. So 110,224. And if I divide that by 4, so divided by 4, let me go over here, refresh this. If I do 332 squared divided by 4, well, it should look at that. I'm going to get 27,556, meaning that regardless how big or small a circle is, if the ratio is the same, it's always going to be 27,556 times the area of the smaller square. Okay, let's go over this question. I'm not going to draw anything because I'm not the best drawer. This is why I'm not an AP art. A cube has an edge length of 68 inches. A solid sphere with a radius of 34 inches is inside the cube, such that a sphere touches the center of each face of the cube. To the nearest in cubic inch, what is the volume of the sphere and the cube not taken up by the sphere? There's a lot of information. Let's go over it. So we're given that there is a sphere inside the cube. What does that mean exactly? That means that the volume of the cube needs to be greater than the volume of the sphere, because if for a shape to fit in another shape, the shape that's inside the bigger shape needs to be smaller. Therefore, the volume of the sphere has to be less than the volume of the cube, because the cube needs to have a bigger volume so that the sphere can fit inside the cube. I hope that makes sense. So let's figure out the volume for the cube and the sphere. Unfortunately, they don't have the formula to find the volume of a cube, but luckily it's really easy to memorize. So I'm gonna write memorize so you guys engrave it into your brain. So memorize it, please. And to find the volume of a cube, so I'm gonna write that volume of a cube. It's just x cubed. So any edge length to the power of 3, that'll give me it. In this case, we have 63. So the volume of the cube in this example equals 68 to the power 3 or cube, and if we plug it in into Desmos, I'm going to get 314,432. So this is 32, sorry, I gotta rewrite that. So 314,432, and this is my volume of cube. So let's go over the other part of information given. So I'm given that the sphere has a radius of 34 inches and is inside the cube. Remember, the sphere needs to have a smaller volume than the sphere needs to have a smaller volume than the cube. So what is the formula to find the volume of a solid sphere? Luckily, it's in the digital SAT reference sheet, so you don't need to memorize it. And if we look, I'm scrolling through everything, and if we look at our reference sheet, I can see that I have the formula to find the volume of a sphere, which is volume, I'm gonna draw in green, volume equals 4 divided by 3 pi r cubed, or r to the power 3. So the good thing about r, it's radius. So for this example, our radius is 34. Basically, the volume of a solid sphere in this example equals 4 divided by 3 pi to the power 34, so 34 to the power 3. And if I plug it into Desmos, so let me open Desmos again. Desmos is really handy, thank God they give it to us. So 4 divided by 3 pi, where's pi? Then 34 to the power 3. I am gonna get, if we round it up to a whole number, because we don't like decimals, as we can see there's no decimals answers here, it equals 164,636. So I'm gonna write that in green. So 164,000, 636. This is my volume volume of solid sphere. What's convenient about that is that I get those two numbers and I can figure out the volume of the cube that's not taken up, but why subtract it? So if the sphere is taking up part of the volume of the cube, there's obviously part of the volume of the cube that's not being used, which is what we're looking for. How can we solve that? We subtract the volume of the cube with the volume of the sphere to figure out the volume that is not being used inside the cube. Therefore, I would want to do 314,432 minus 164,636, and that will give me my answer of the volume of the cube that's not being used. So 314,432 minus 164,636, I'm going to get a number of 149,796. So 149,796. And if we look at our answers, A matches with the answer that we found by subtracting the volume of the cube and the sphere, meaning our answer is A. Okay, let's do another question. A cube has a surface area of 54 square meters. What is the volume in cubic meters of the cube? So I'm not drawing a cube. I'm not gonna draw a horrible art for you guys so you guys get confused. No. So what is surface area? What is the formula of surface area? So surface area is basically finding the area of the square and then multiplying by 6. Because let's think about it. A cube has 6 sides, right? And each side represents a square. And the square obviously has an area. So each side of a cube has an area of the square. And to find the surface area of a cube, I multiply the area of the square times 6 because there's 6 sides of the square, basically showing the full, we're adding all the areas of the squares combined. So we do 6 multiplied by the area of the square. In this example, we have the surface area of 54 meters. So surface area, so I'm just gonna write that, equals 6 multiplied by, let's say, s squared. Because if I remember, a square has 4 equal sides, and to find the area of a square, I just need to multiply two lengths, or 2 parts of the square. So if, for example, I have the side length of 4 on each side of the square, I do 4 squared, which gives me 16, and then 16 times 36, that'll give me the surface area. In the next example, we have a surface area of 54. So 54 equals 6s squared. And we're looking for s because we need to figure out s to figure out the volume of the cube. Because the cube has edges, and if we find the length of the edges, we can look for the volume of the cube, because as we did in the previous question, volume of the cube is x to the power 3 of the edge length. So let's solve for the volume, or the length of the square. So if I divide by 6 on both sides, I'm going to get 9 equals x squared. And we find the square root on both sides. These cancel out over here, so I'm left with s equals square root of 9, which s equals positive and minus 3, but it can't be negative 3 because that doesn't make sense. So s equals positive 3. So now I have s, and each edge length of a cube is 3 now. So all I have to do is do 3 to the power of 3, or 3 cubed, and that'll give me the volume. So 3 cubed equals 27. Therefore, my answer is B. And remember, surface area is just multiplying the area of a square times 6, because there's 6 sides in a cube. Okay, let me do another question. A right triangle has the lengths of 2 square root of 2, 6 square root of 2, and square root of 80 units. What is the area of the triangle in square units? So let me use the information given to figure it out. So I'm given a right triangle, obviously. Whoops, that is very thin. So let me change that. I have a right triangle, right? And I'll have 3 side lengths. 2 square root of 2, 2 square root of 6, and square root of 80. What I'm looking for is find the area of a triangle. And as we went over in a, not a previous video, but in a different question, the area of a triangle equals 1/2 base times height. And the base is over here, and our height is over here. Well, why is that important? If we look at the right triangle, the hypotenuse is not used. Therefore, the hypotenuse is not used in the formula. The hypotenuse is always the longest length of a triangle, whether it's isosceles, cube, obtuse, equilateral is a little bit different. But you get the point. The hypotenuse is always the longest side. So what we want to do is figure out which of the following side lengths is the longest side, so we can cross that out and then multiply the other 2 numbers to figure out the area of the triangle. So let's solve it now. So if I were to do 2 square root of 2, so let me rewrite that. 2 square root of 2, I can rewrite that as square root of 2 multiplied by 4. Why am I able to do that? Well, we can't find the square root of 2, but we can find the square root of 4, and square root of 4 equals 2, so we move that to the outside. Anytime we have a big number and there's a square root, or there's a number that can be square rooted, and we have a number that can't be, we leave the number that cannot be square rooted in the inside, and a number that can be simplified, move it to the outside. Therefore, 4 can be simplified to 2 on the outside. So therefore, 2 multiplied by 4, that equals square root of 8. And if we do 2 square root of 6, so 2 square root of 6 equals, no, 6, I wrote that incorrectly. It's 6 to the square root of 2. That is my mistake. See, this is why I gotta pay attention. So let me make that green. So 6 square root of 2 equals square root of 2 multiplied by 36, which equals square root of 72. Now square root of 80. So let me rewrite all the lengths that are given. I have the square root of 8, square root of 72, and the square root of 80. And if I look at all my numbers, 80 is the longest side. Therefore, 80 is our hypotenuse, so you want to cancel that out. So I have my 2 lengths, square root of 8 and square root of 72. So now I can figure out my area. So let me rewrite it as the way it was, the square root of 2 and 6 square root of 2. So area, or A, equals 1/2, and then 2 square root of 2, write that in parentheses, multiplying 6 square root of 2, which the 1/2 multiplies by 2, which cancels out, and the 2 multiplied by 6 gives me gives me 12. Or actually it gives me 6, sorry. I wrote that incorrectly. Because this cancels out. So I'm left off with square root of 2 multiplied by 6 square root of 2, which equals 6 to the square root of 4. And I can rewrite that as equals 4 multiplied by 36. And 4 multiplied by 36 equals square root of 144. And the square root of 144 equals 12. Therefore, my answer is B. That's the end of the video. Thank you for watching.